Kia ora Year 11 and 12. This video is going to go over the harder locus problem that I've emailed you notes for. I'm making it because lots of you were off at school at the climate change strike or at Runathon on Friday. If you're watching this and you're not from my class, it's going to be even clunkier than my usual videos because it follows on from a discussion we had about a problem in class the previous day, which is the day the fire alarm went off. And that first problem that we did was a locus problem, a lot like this one, but we did it algebraically. Okay, so the problem we're going to look at today is slightly different. It's this one here. I've just changed the numbers a wee bit. We're trying to find the locus of points that satisfies this condition. Now we can do it algebraically, and that's how we did it in class the first day. That gives us a circle, but it doesn't give us much intuition for where that circle comes from. It also leaves in a little bit of locus that shouldn't really be there, right? So the circle equation gives me a whole circle, but we're going to find that today what we end up with, without giving away the punchline too much, is going to be a locus that looks like this. This is going to be 2, and this is going to be 6. And my centre of the triangle is going to be up here. So actually, for once, I'm going to give you the answer before we start. The equation that we're going to end up getting is the equation of a circle. And it's going to look like this one. It's going to be x minus 4 squared plus y minus 2 squared is equal to 8. Remember that the equation of a circle fits this pattern. X minus x naught squared plus y minus y naught squared is equal to r squared, and that's for a circle with the centre at x naught and y naught. So drawing it like that, we can just about see where we're going to end up now, right? So this is going to be a right angle here, and the angle at the centre is always twice the angle at the circumference. So anywhere on that circle, I'm going to have pi on 4. Right, so the next 5 minutes are going to be me trying to show you how we can think about that and how we can draw it in Geogebra. So this video is going to be clunky because I can't use the stylus that well when I'm in Geogebra, but we'll give it a go. So we're going to start by looking at how we can solve this geometrically by taking this arg and splitting it up. Right? Remember that when we learnt about multiplication and division in polar form, we saw that the arg of z1 over z2 could be split up into two separate arguments. The angle formed by z1 in the x-axis, in the positive direction, minus the angle formed by z2 in the positive direction of the x-axis. So we're going to say that the arg of z minus 6 is theta, and then we're going to say that the arg of z minus 2 is phi. And that means that we get this condition. So we're looking for where is theta minus phi equal to pi on 4, and then we're going to find all of those points and find an equation for those points. And we're using circle geometry. So this is my general situation before I'm fixing my angle at pi on 4. So where on the picture can we see theta minus phi? Right, so where is that? Well, let's have a wee look. So back to Year 9 geometry, this angle in here is 180 minus theta. So we're trying to figure out where we can see this, and we can see it in two places on here. Angle APB, so this one here, is going to be 180, because angles in a circle add up to 180. 180 take away phi, take away angle ABP, which is 180 minus theta. Right, so it's 180 take away this one, which gives me theta minus phi. So that means that this angle is what we want to be 45 degrees. Or we can think about this one here as being 45 degrees. Okay, so now we're going to go over to Geogebra and try and just trace out by hand where that happens. Right, now this is the third time that I've made this video because this keeps coming slightly unstuck. So please be patient, but what I want you to look at here is this. This angle here is going to change as I move point C. But I can see that point A has also managed to lift up from where it should have been. So this needs to just move a little bit. So A needs to come down to here. There. Right, so A is in the right place now. So I'm going to try and move C. So look what's happening. As I just randomly wiggle this around, the angle that's formed is not 45 degrees. So let's see if we can find the first place where it is. So you can see we're getting warmer, getting very close now to 45 degrees. And I'm going to stop when I get pretty close. It's quite mesmerizing right now. I'm going to stop now. That'll do. I'm going to mark on that first point with a dot. This is called low-tech GeoGebra. Right, now, if I keep going around here, let's see, where am I getting 45? Nope, I'm going the wrong way. Here we go, we're getting very close out here. Right, I'm going to put another dot here. Here's my next dot. Right, let's keep on going. I'm going to find a few more so that we can see the circle getting traced out. Too small, right, close in here. Right, pretty close. Another dot. And then let's go over here. Getting really, really close into that point at 6. There, that'll do. Oh, bit too big. So that's good enough that now I'm going to do one more tracing of point C. So up here, let's see if I can find a 45 there, very close to 45 there. So one more dot right there, and now I'm ready to draw, freehand, we'll see how this goes, a circle. Look at that, oh, it worked! It even put a circle in. Now that circle, sorry, I'm quite excited about that, I didn't know GeoGebra could do that. That circle, of course, is meant to go right through point A, but it's working off the very dodgy points that I drew with the pen. So what we need to do now is to go back and say, well, I really, really need to find the equation of that circle. But there are a couple of things that can help me, and I'm going to show you while we're over in GeoGebra what they are. We know that this point is on the circle, and we know that this point is on the circle. So because that angle in there is 45, what we want to do to write the equation is to find the center of that circle. And I don't know really where up and down this is here. So let's go back over to OneNote and do it by hand. Okay, well we know about the angle at the center rule. So if we've got our points here, if the center of the circle's in here somewhere, what can I say about it? Let's put it here. And we can draw that anywhere. So that's 45, and that is 90. Now, we're getting a triangle formed here with the center. If that's 90, let me take off some of these terrible lines. Let's take off some of this. Think about where the center is. Say my center is here. Well, we know that A is on the circle, and we know that B is on the circle. So that means that if we call that O, and we draw this in, this must be a radius. And this must also be a radius. Now, since the angle at the center is 90, that means that this angle must be 45 degrees, and this one must also be 45 degrees. So we can use that little isosceles triangle to say, hey, what are the coordinates of this point O going to be? And this is 2, 0, and this is 6, 0. But if this is R and this is R, we've got an isosceles triangle. So we're really going back to basically year 10 or year 9, or earlier for some of you, geometry. Because this point here is going to be important, and that point is going to be 4, 0. Right? Because it's an isosceles triangle, so we've got reflective symmetry. So I've written some of that up in the notes more formally. Let's have a look. Right, so here's my little drawing. This is point X here. And we know this length R, but we don't know how long it is. But if you just draw out one of those triangles, so let's draw out OAX, this is, we know that this has got to be 45 degrees, right? Because that whole thing is 90. And if this is 90, and this bit here is 45, that means that this must be 45 degrees as well. But now we can get the centre very easily because we know that this distance from here to here is 2. So this side length must also be 2. And that means that finally we can use Pythagoras to get this distance here, which is r. Okay, now, so I want to draw out that triangle one more time. Right, so this is 2, 0, and this is 4, 0, and this is the thing we don't know yet. But we know that this is 2, and we know that this must be isos, because that's 45 and that's 45. So this is also going to be 2, which means the coordinates of O are going to be 4 and 2. And r squared is equal to 2 squared plus 2 squared, which is equal to 8. So finally, we're ready to write the equation of that locus. I'm just going to go back up to the page where actually I'll go back to Geogebra. So what's the locus of this? Well, the centre is here at 4, 2. And the equation is going to be x minus 4 squared plus y minus 2 squared is equal to r squared, which is 8. Okay, so that's how we get the equation of that locus. Now, what I suggested you try for homework is what happens when we do our earlier example, which is this one. The arg of z minus 2 over z plus 5 is equal to pi on 4. The numbers aren't quite as nice, but the basic picture that you should get will be very similar. So not doing it in GeoGebra, doing it very badly here, we're going to have 0.2 here, we're going to have the point -5 here. So knowing that that's going to form an arc on a circle, where is my centre going to be? Well, I'm going to have the same isosceles triangle idea. So this length here is 7. Half of 7 is 3.5. So the centre is going to be at -3 over 2. And there's going to be a little isos triangle formed in there as well. So that length is 3.5. This point here is going to be 7 over 2. Circle's going to go like that. Right, it's a really terrible circle. But we can see already that we can quickly get ourselves to the equation. Right, and the equation is going to be x minus 3 over 2 squared plus y minus 7 over 2 squared. And then all that's left to do is to work out the radius. Right, but the radius will be, so r squared will be, what have we got? 7 over 2 squared plus 7 over 2 squared. Right, so the 7 over 2 is that distance there, and that distance there, and then r will be here. So r squared will equal 49 over 4 times 2, because we do it again, which gives me 49 over 2. And you'll remember that this is exactly what we got, thank goodness, when we did it algebraically. So that's my locus for that one. And then we also have to state that we want y to be greater than or equal to 0. Okay, so bits on here that we want to erase. Oh, I've erased the whole thing. Never mind. Okay, so we just want to have the circle that goes around like that. Okay, thank you very much for your patience. I hope that made sense. The worksheet that I'm making you is going to have some more like this to practice and some slightly harder ones. Thanks for watching and enjoy the rest of your Sunday.